Okay, so we're going to go back to section 7.2 of our textbook and look at trigonometric integrals. So let's start with some easy ones first. So what is a trigonometric integral? It is one that's in the form, we're going to start with, there are a couple forms for these, but we're going to stick with the sines and cosines. So it'll be in the form of the sine to some power m of x times the cosine to the nth power of x dx. Okay, that would be the form that we're looking for. Okay, so we have some combination of sines and cosines. There are also other ones that we're not going to look at involving tangents and secants. We'll leave those for another time. So let's start with the really easy ones. Okay, so level one is something you actually already know how to do. Level one is where m or, the word or is key, n is equal to 1. All right, either m or n could be 1 or both. All right, so let's look at an example of this and see why it's easy. The reason it's easy is because you already know how to do it. If I simply write this, all right, then let's go ahead and figure out what this would be. All we need to do is our former method of U substitution. All right. Now we have a choice. There's complete symmetry here. All right. We could either let U be the sine of x or let U be the cosine of x. Given that the derivative of sine is positive, I will let U equal the sine of x, but it really doesn't matter. That makes du dx equal to the cosine of x. So du is equal to the cosine of x dx. And you can do either method. I would right away just say, all of that is du. So in this case, it's easier, I think, just to substitute du in. And so our integral becomes the integral of sine of u is u, du. So it's simply u squared over 2 plus c. If we substitute back in, we end up with 1/2 the sine squared of x plus c as our answer. So you can see how easy that is, all right? We could have, like I said, if you wish, you could have solved for dx here. Some of you like this method the best, where you say dx is du over the cosine of x, and you would see that the cosine of x canceled out, but you'll end up with the same answer. All right, so let's just do a couple of more and make sure that we understand how to do this. So we could have used this method, by the way, if we had the sine of x over the cosine of x dx. By the way, that's the same as the tangent of x. So this is how we could figure out the antiderivative of the tangent of x. So we've seen this one before. In this case, the power of the sine is 1. The power of the cosine is -1. So in this case, you don't have an option. You have to let u equal the cosine of x. It doesn't work if you let u equal the sine of x. Therefore, du dx is the negative sine of x dx. So if I just put a negative here and here, looks like I have du in the numerator. Let me solve for du. Du would be negative sine x dx. So by putting those two negative signs in, you end up with the integral of du over u, which we know is ln of absolute value of u plus c. Substitute back in, that's the natural log of the cosine of x plus c. That works out very nicely. If you wanted to do the other method right here, you could say dx is equal to, oh, I'm sorry, I messed up. The dx wouldn't be here yet. It's down in here in this step, but I could solve for dx and say that it's du over the negative sine of x, and you would see the sine of x is cancel. So either method, this is the alternate method for doing that, which many of you like. I could work, there's another example. What if I had the integral of the square root of the sine of x times the cosine of x dx? This would work out nicely. Notice the cosine of x is to the power 1. So I'm going to want to substitute for the other one. All right. Substitute for the more complicated power and leave the one to the first power alone. So let's look back at our first 3 examples. In example 1, there's complete symmetry. Both things are to the first power. So subbing for either sine or cosine works. In the second one, the sine of x is to the first power, so we substitute for the cosine of x. In the one I'm about to do, cosine of x is to the first power, so I better substitute for the sine of x. So du dx is cosine of x. Du is cosine of x dx, which we have right here. So I can rewrite this. We do it on the same line. This becomes the integral of u to the 1/2 power with respect to u. That will give me 2/3 u to the 3/2 power as the antiderivative plus c. Substitute in 2/3. Looks like we have, let me just be careful, the sine of x to the 3/2 power plus c as our answer. Okay, let me do 2 examples where there are limits of integration. So let me start with this one. I think this gets us up to example 4. If I had the integral from 0 to pi over 2 of sine squared x cosine of x with respect to x, the key is we need to substitute for the more complicated one. Cosine of x is to the first power, so we're going to want to not substitute for that. So we will want to substitute for the sine of x. That'll give us a u squared. So du, we've seen this a couple of times, so I'm just going to go right to cosine of x dx. So all of this in parentheses is du, all right? But now this has limits, so let us be careful. The limits were originally for x, so let me make a little table of x versus u. When x is 0, u is, remember, the sine of x. The sine of 0 is 0. When x is pi over 2, u would be the sine of pi over 2, which is 1. If you forget, I often do, just real quickly, look at the y values at 0 and pi over 2, and those will give you the limits for x. So let's come back here, and we can rewrite this as the integral from u equals 0 up to 1 of u squared du. Remember that the sine squared of x, sine of x is u, so we have u squared, and everything in the red parentheses would be du. So we can say this is equal to the integral of 1/3 u cubed, or u cubed over 3, evaluated at 0 and 1. So we end up with 1/3 minus 0, or just 1/3. Okay, so that came out very nicely. Let's do one more of those. Let's do the integral from 0 to pi of sine x cosine to the 4th x dx, all right? So you can see the sine of x is to the first power, so don't substitute for the sine of x. We want to substitute for the cosine of x, because its derivative will be almost the sine of x. So let u equal the cosine of x. Therefore, du dx is the negative of the sine of x. So du would be the negative of sine x dx. If I put double negatives in, I can link what's underlined with the dx, and I have du right there. Or if you prefer, you can use that dx is equal to du over negative sine of x, and have the sine x cancel out. So I can rewrite this as the integral. Oh, we're going to have to check the limits. But sine x dx is du. So we have, and then cosine is u. So we have u to the fourth du. Let me just do my little limit table up here. When x, we'll put x and u, remember this is cosine of x. When x is 0, cosine of 0 is 1. And when x is pi, cosine of pi is -1. All right. Okay, so we're going to go from 1 to -1. And I did forget one important thing. I forgot that I had this negative sign out here. And I like that there's a negative sign out there because you can see my limits are sort of upside down. I go from u equals 1 back to u equals -1. So let me turn the whole thing right side up and go from -1 to 1. That introduces another negative, which cancels the negative in front. So I'll have this as my result. The antiderivative of that is u to the 5th over 5, or if you prefer 1/5 u to the 5th, either way is fine. Evaluated in -1 and 1. Substitute the 1, and you get 1/5, minus substitute the -1, and you get -1/5. So the answer is not 0, it is 2/5. Okay, so with those examples, actually we're going to go into another video before you attack the homework problems.